Assalamualaikum warahmatullahi wabarakatuh. Good day to the moderator, professor, doctor, lecturer and all the audience. My name Muhammad Noor Farhan. I will represent the research project with the title Formulation and In Vitro Evaluation of the Standardized Eurycoma longifolia root water extract loaded niosome for the immunomodulatory effects. This is my presentation content. For introduction, Eurycoma longifolia is a very famous local traditional plant, also known have potential human energy booster, and then this plant come from Cimarobaceae family. This plant, locally known as Tongkat Ali, have shown to have potential anti-inflammatory and immunomodulatory activities. These anti-inflammatory activities is proven by inhibiting the expression of NF-kappa B and the COX-2. Promising data from the randomized clinical trial on this plant exhibit the immunomodulatory effect by increasing the total naive and CD4 T cell. This plant extract have a plenty phytochemical compound. One of the compound known as Eurycomanon, the most abundant marker and have potential anti-inflammatory activity. Viability of this extract shown that the Eurycomanon exhibit low viability in rat and mice. Therefore, it may reduce the therapeutic effect of the extract. To enhance the therapeutic effect, we must enhance the bioavailability of the standardized extract. So we need to introduce the nano formulation containing the extract in this study. So we choose the niosome as our nano formulation and the drug delivery system. Niosome, a very small and microscopic in size, consists of aqueous core enclosed in a bilayer of cholesterol and one or more non-ionic surfactant. Niosome is biocompatible, biodegradable, non-immunogenic and non-carcinogenic. Niosome can improve bioavailability and stability. Niosome also can help to deliver drug to the targeted site of action. For the objective, general objective for this project is to investigate the immunomodulatory activities of the niosome formulation containing the extract through in vitro assays. Specific objective: number 1, to optimize the niosome formulation containing the extract. Second, to evaluate the physicochemical characterization of the optimized niosome. And the third one, to evaluate the potential immunostimulatory activities of the optimized niosome. For the methodology, the study design, first we do formulation, second we will do the in vitro cytotoxicity on 3 different cell line, and then the third one we will do the in vitro efficacy assays. For objective number 1, to optimize the niosome formulation, 3 surfactant will be formed lipid phase and then extract will form aqueous phase. Lipid and aqueous will be mixed and stir and proceed to the propsonication at 70% maximum capacity. Then the niosome formulation is formed. The niosome formulation will be evaluated for the physicochemical characterization such as particle size, polydispersity index, pressure stability, pH measurement and morphology. To evaluate the immunostimulatory activities, we will measure the nitric oxide release using the raw cell. The cell will be treated with the lipopolysaccharide stimulated by treatment at different concentration, and then add the grease reagent, continue measure the absorbance. And the phagocytability will be measured using THP cell. The cell will be and treated at different concentration, and then latex bead IgG Fc followed by Duffy will be stained to the cell, and then the engulfment of the bead can be accessed by counting the individual cell using high content imaging system. Now we proceed to the result and discussion. Table 1 is the physicochemical characterization of the standardized E. longifolia root water extract loaded niosome formulation. So this one is the optimized niosome. So the diameter size will be 231.5 and the PDI value is 0.1. Niosome formulation meet the requirement for the oral route application as the diameter size can be adhered to the human colorectal is in the range of 50 to 500. PDI value describe the uniformity of the particle distribution in the Niosome formulation. A small PDI value indicates uniformity and can be considered as a monodisperse formulation. The stability of the formulation will be determined by three parameters: is the diameter size, pH, and physical appearance. Diameter size of the formulation increase gradually from day 0 until day 90, but not much different. There is not much changes in pH value and indicate the formulation is stable and monodisperity. No physical separation were observed at the formulation until day 90. Morphology of the structure. The structure will be determined or evaluated using the scanning electron microscope. At the picture A, at 1000 magnification, you can see the structure of the Niosome in the red circle. And then at the B picture, at 30,000 magnification, you can see the individual Niosome structure. Formulated Niosome vehicle were found to be spherical in shape. The particle size observed will range from 231 to 771 nanometer. Now we proceed to in vitro cytotoxicity assay. Table 2 represents the inhibition of cell growth after 72 hours exposed to the formulation and the extract itself. There is a 3-cell line will be used in this study. The formulation show less toxic to the THP1 followed by a raw cell and the Vitro cell. The standardized extract shown IC50 more than 100 microgram per ml to the host cell compared to the formulation. This is because the Niosome ingredients such as twin span cholesterol are lipid based, which may contribute to the inhibition cell growth by interfering A exchange on the surface of the monolayer cells. Now we proceed to the in vitro nitric oxide release assay. The figure 3 represents the nitric oxide release compound measured after different treatment to the LPS-induced murine macrophage raw cell. The nitric oxide compound release were calculated after exposed to the formulation 12.5 microgram per ml was significantly different compared to the curcumin, which is positive control. At concentration 12.5 microgram per ml, the Niosome provide anti-inflammatory activity to the LPS-induced raw cell, which means that it can deactivate the raw cell. Meanwhile, nitric oxide compound were released at high value when no treatment given to the LPS-induced raw cell. And also curcumin, also known as the anti-inflammatory activity. In vitro phagocytic assays. Figure 5 shown that immunofluorescent imaging of the THP1 cell. Blue color represent non-phagocytic cell, while greenish color represent phagocytic cells. And then from this picture will be transformed to the graph, which at figure 6. Percentage of the phagocytic cell of THP1 were calculated based on the phagocytic cell over the total cell counted in the 2 captured field. So here you can see the similar profile you can see as in the nitric oxide release assay, which means that the formulation have anti-inflammatory similar to the curcumin group. Cytokine expression. Table 3 represent 5 cytokine expression were determined after exposure to the 4 group. So from here, the interferon gamma, interleukin 6 and interleukin 1b cytokine level markedly increased after exposed to the formulation 12 microgram per ml and had similar profile with the curcumin, which is the positive control. This data is supporting the mechanism of action of anti-inflammatory activity for the Niosome 25 microgram per ml, which is similar to the curcumin, which is the positive control. As conclusion, the standardized E. longifolia root water extract was successfully developed and can be further used in the in vitro viability and in vitro study. This is my reference, and thank you for listening.